Welcome to Speech Enhancement course. In this video, we will see the basic steps and procedure involved in processing the speech in frequency domain for the speech enhancement process. Consider here ST is the source speech signal, and here let us consider this NT is the noise. See, the speech spoken by this person is affected with the noise coming from this source. The noise is adding with the actual clean speech, and hence the noisy speech is created at this transmitter section here. Now this noisy speech is transmitted and the listener is listened that noisy speech. Then the listener faces some discomfort and some fatigue to hear the speech. So that's why what we are doing is we are going to process this noisy speech by using the speech enhancement algorithm, and then the enhanced speech is going to be sent to the receiver so that the listener fatigue may be reduced, the discomfort may be overcome to some extent. So here the important point is we are assuming the noise is additive with the actual clean speech signal. With this assumption, if you develop the speech enhancement algorithms, the algorithms works well for the actual real-time noise removal. So that's why generally the additive noise is assuming here. So this is the noisy speech here. Now how to process this noisy speech and what are the basic steps involved in processing this noisy speech in frequency domain. So first of all, this noisy speech is going to be splitted into, that is framing into short segments which is having 0 to k minus 1 samples here. Let us consider, right? So on that 0 to k minus 1 samples, that is the first short segment. On that first short segment, I am applying the window which is having samples 0 to k minus 1 samples, right? That is, I am selecting 0 to k minus 1 samples here, and on the 0 to k minus 1 samples short segment, we are going to applying this window, right? This is the first window, this is L minus 1 window, and this is L minus 2 window here. Now the next frame also we are going to apply the framing, but here the overlap framing is used here to avoid the discontinuous here. Overlap framing is used here. That is, from 0 to k minus 1 we have applied the first frame and windowing, and second window is applied with some overlap between the first 0 to k minus 1 samples and then next frame samples. So like that the overlapping windows are used for framing and windowing. Now we got the framed and windowed signal here. Now this is, if you see the short time duration, then that the assumption of stationary holds good, and now upon that short segments after windowing of k samples here, we are applying the DFT on each windowed frame. So after DFT, the time samples are going to be converted into here DFT coefficients. So the DFT coefficient is marked as capital Y, K, comma L, where K indicates the number of samples here, right, 0 to k minus 1 here, and L decides the frame, right. And the DFT coefficients in frequency domain are used for speech enhancement process. After that one, the coefficients of Y are modified by using the required algorithm and resulted in S cap, where S is the clean speech and S cap is the enhanced speech, which is in frequency domain here, and that frequency domain is converted to time domain back by applying the inverse Fourier transform, that is inverse DFT here. Now here what you have to do here is, here you have to do the inverse process of this here. Why? Because here overlap windowing is applied here, so here overlap add and save method is used to again get back the actual original time domain signal, which is a enhanced speech signal. So these steps, framing and windowing, and here overlap add and save method, we are reconstructing the time domain signal. These steps are common for any algorithm. So we'll write the MATLAB code such that the only change in the total MATLAB code for the enhancement is the speech enhancement algorithm. Right. So first we will see how to write the basic steps here in the MATLAB, and then we will see different additional algorithms for speech enhancement and how to implement that using MATLAB. Thank you.